So our build today, guys, will be a function generator that will be able to produce a square waveform in order to get this MOSFET to quickly turn on and off in order to run this ungodly transformer I decided to pack in resin and put it inside because the dielectric material was always failing on me and I got bored of the Chinese bullshit going around, so I took some resin and this is it. Never had a problem with it again. So yeah, excuse my ranting about the Chinese transformer. So this is the circuit diagram. As you can see, we connect pin 4 to pin 8 and pin 2 to pin 6 in order to get the chip working into a stable multivibrator mode. And after that, well, I'll show you what we do after that. Let me get the chip on the board and do the connections, meaning let me connect pin 4 to pin 8 and pin 2 to pin 6 and we'll go over from there. I also didn't mention pin 1 is ground, pin 8 is VCC. So I've inserted the socket like so, and now I'm gonna insert the chip into the socket with the front side being here, yeah. Like so. So pin 1 is here, pin 8 is here, so you can see the circular depression I was talking about is this way. So we'll draw 2 lines of solder to this side and also add a clamp so we can power the device later. So now let me solder the pins. So as you can see, first of all, connecting those two, pin 8 to pin 4 and pin 6 to pin 2 was a bitch. But anyways, so I've gone already and attached an input clamp, a power input clamp, and drew 2 lines of solder to VCC, to ground, and 1 to VCC, which is pin 8. This is pin 8, this is pin 1. Now let's start adding the resistors and potentiometers. So we will add a 560 ohm or half a kilo ohm resistor and a 10 kilo ohm potentiometer in series and connect it to pin 7. Then from pin 7 we will connect another half kilo ohm resistor to another 10 kilo ohm potentiometer, and we will connect that to our VCC, our positive. So let's start doing that. So we've taken from pin 2, as you can see, a half kilo ohm resistor. Pin 2 is here where the yellow wire is, and join it with the potentiometer over here, and with a jumper wire connected it to pin 7. I know it doesn't show on the camera, but I assure you it's connected to pin 7. Now we do the same thing. We add half a kilo ohm resistor from pin 7 and another 10 kilo ohm potentiometer, and we feed that into VCC. So as you can see, we've added the half kilo ohm resistor from pin 7 from this pin to this potentiometer and fed the potentiometer into VCC. VCC is here and ground is here. Now we need to add a capacitor. That capacitor will determine our frequency range. You can go up to, I don't know, 10 microfarads and get a signal in the range of a few hertz, or down to, I don't know, maybe a couple of picofarads and get a signal range from thousands of kilohertz to 1 megahertz, which is the maximum this chip can achieve, is about 1 megahertz. So we'll be going with 1 nanofarad capacitor. Let me add the capacitor, which is added between 1 and pin 2 over here. And as you can see, we've added this tiny ceramic capacitor. That's 1 nanofarad between pin 1 and pin 2. Now the output of this device is on pin 3. Pin 3 will output pulses, and we will be able to change the frequency of the generator by turning the knobs on the potentiometers. However, we have a little thing extra to do. We need to add a second capacitor. This is optional, but I usually do it because it helps with the waveform. It's more clean that way. To add a capacitor on pin 5 and connect it to ground. So let me do that. And like so, I've added the, I don't know if it shows, 10 nanofarad capacitor yeah, over here, and connected it to the ground on pin 5 and connect it to the ground. Now let's add the 10 ohm resistor and check it out with the oscilloscope and see some waveforms before adding the MOSFET. As you can see, if we place the oscilloscope's ground to our ground over here, that connects to the generator, and the probe on the output pin, that is this resistor that is connected to the output pin on pin 3, then we get a square waveform which I can change by changing the value on these potentiometers, like so. Let me find a way to do that. Yeah, that will work. Nope. So, as you can see, as I turn the knob, I can adjust the frequency while I am increasing the frequency. Right. Yeah, there you go. And this circuit has a frequency range of 44 kilohertz to about 92 kilohertz, where the duty cycle becomes so small that it's not a pulse at this point, so the scope goes kind of crazy. So yeah, we will continue with another one. We will add a MOSFET now and show you how to run the MOSFET with the generator. So now we will add the MOSFET over here, which is going to switch the power. I'm gonna feed the 10 ohm resistor into the base as a signal and connect its ground to the ground. Add a clamp over here, connect one side to VCC and connect the drain to the other side, and connect whatever load we want in this clamp. So this is our circuit and it's ready to be used. As you can see, I added the MOSFET over here and added an output clamp. The drain of the MOSFET is connected to the one side of the output clamp. VCC comes from, VCC comes from VCC over here, and disconnected on the other side of the clamp, and ground comes from ground here and is connected to the source pin of the MOSFET, and the load is placed between VCC and drain, meaning this clamp. So now let's place a load, an inductive load, which is this transformer between those clamps, and see how it performs. So as you can see, the high voltage is even passing through the insulation of the wire. I bet if I get it over there, it's gonna draw an arc. And yeah, it does draw an arc. You can hear the high voltage, you can see between the loops of the wire. And funny, oh shit, I shot myself again. It's interesting to see the effect that we have. Let me turn off the lights. So as you can see, now in the darkness I've turned all of the lights. The corona discharge that forms between the insulation of the wires, and it's really beautiful. It produces ozone, which is quite smelly. It's like welding metal or something. It smells like bleach and has a very strong smell to it. It also does that on your arm too. It's very interesting what the high frequency can do. Yeah, that's all with a square waveform coming from this little chip, the 555 chip, this power MOSFET. Anyway guys, that was all I wanted to share with you today. Also, give me a moment. So this is how the MOSFET connects. Signaling goes from the ground like that, goes square waveform. So the MOSFET switch is on and off, letting current pass through while doing so it drives the primary coil of the transformer. You could add a capacitor here to make it a resonant LC tank. You could do that. I didn't do that. Maybe get more efficient or something. And yeah, this is the multiple loop, like 1,000 or 10,000 loops. I don't know how many loops the secondary has, but it does have a lot of thousands of loops, and that's how you get your high voltage out. So back to the basic diagram. The pulse is coming out of pin 3, and again ground is pin 1. So that's how you run a transformer from a function generator using a MOSFET powered by the 555's IC. I hope you guys liked it, learned something, and I'll see you soon with another experiment. Have fun till then, and Chandra Goose signing out.